whether or not we can see this. Let's go to 125, and let's go to 150. Okay. It's a little blurry, I apologize. But you go ahead and stop me if there's either an even that you're missing or that you are marking wrong and you don't know why, or if there's an odd close that you want me to talk about. Number 4. 3, 3, 3. Why is the function not continuous at -3? Yeah, it doesn't equal the point. So the limit exists, right? Coming from below, or coming from above, coming from below, agree. The limit exists, but it doesn't equal the point. Number 18. Oh, that's not going to work very well, is it? Ali. Yeah. Okay. You guys can start checking number 18 and number 32. Let me peek at number 5 really quickly. Number 5 was another graph, and number 5 gave you a piecewise function with one branch from the left and one branch from the right. What did you guys answer for the limit for letter A on number 5? Because what are you approaching on number 5? What's your C? 2. And doesn't the top branch, does it come from above and hit? Is that right? Switch? Oh, it's under the axis? Perfect. Okay, so then as we, letter A, as we come from above, F or G or whoever he is, what was this height that this branch is approaching? 3. And it's actually hitting there, but either way, it's approaching and it's hitting. The limit is just the approach, 3. And then letter B, what height were you approaching from below? -3. The approach is -3. So then, Ali, what do we do when the one-sided limits don't agree? Not continuous, that's true. So we would say the third one, letter C, the limit, which takes into account both, would not exist. Does that make sense? So first of all, the limit doesn't exist. And second of all, the function is not continuous. Why? F of 2 is undefined? No. It's from condition 2. The limit doesn't exist. So that's why the function is not continuous. Does that make sense? Okay. Going back to our answers, number 18. There he is. Number 18, from below, we got 3. From above, we got 1. Therefore, the limit does not exist because they don't agree. Yeah, AJ. No. Remember, limit is not about at, not about equal. It's about approach. It's about not equal. So when we have piecewise functions with greater thans and less thans, we have to come from one side, one branch, and then the other side, the other branch. So we could do different branches if we have greater thans, less thans. But if we have not equal to's and equal to's, for limits, we totally ignore the equal to. Number 32, do you guys already see it? Why does 1 not work? Remember, the point has to equal the limit. The point would be 2, and the limit, well, wait a minute. As you come from below, plug it in, 1. As you come from above, plug it in, 1. The limit is 1, because those two agree. But is 1 equal to 2? That's why the function is discontinuous. It fails condition 3. The limit is 1 as you come from below and above, but the point is at 2. They're not the same. Number 38. Why is it a non-removable discontinuity? I saw a few of you guys get stuck on this one in the pictures. I wasn't sure why. Why is it, first of all, why is there a discontinuity at 6? Denominator can't be 0. Why is it a non-removable, aka a vertical asymptote? Yeah, you can't reduce. That's one way of thinking about it. Removable, you can reduce and cross out. Or you can also think about it, what happens if you plug in 6? Number over 0, infinity and beyond, that's a vertical asymptote. 0 over 0 would have been the whole. Now they go a little bit deeper and say, oh, because the limit does not exist. Well, they're saying because you have an infinite. I would have said because it's a vertical asymptote. I would have said because it doesn't factor and reduce. That's what I personally would have said. The limit, it's not a bad description, but a hole, for a hole, the limit should exist. For a vertical asymptote, the limit equals an infinity, which is why they say technically dne. Number 48, did you guys factor in properly? And see that -2 is removable because it factors out, and 3 is non-removable because it doesn't factor out. They went ahead and did the whole like, hey, a hole still has a limit. Okay, whatever. But non-removable is at 3 because it doesn't reduce, and removable at 2. I don't see any hands, so I'm still going. Number 54. Number 54. Why are they saying a possible discontinuity at 2? What do we call 2 in class? Separator. Good, good, good. So separator, we have to see if the branches are meeting up, right? So are they meeting up? Where's this guy going? Plug it in, plug it in. -4. Where's this guy going? Plug it in, plug it in. 4 minus 8, -4. -3. Is that what they found? Uh-oh. If they're going 2 different places as you take the limit, the approaches, is that good? The limit does not exist. Therefore, the function is truly discontinuous. So what is the point? -4. What is the limit? dne. Oh, forget it. Discontinuous. Oh, it keeps moving problems. Number 66. Did you guys factor your difference of squares and cross out and just get x plus a and then plug it in, plug it in, plug in what? Well, whoever x is approaching. So plug in a. So a plus a is 2a. Why did they set 2a equal to 8? Did anybody get stuck on this one? Okay, this one was kind of weird. What was the function? Wasn't it a piecewise function with a not equal to and an equal to? What was it, number 66? Was it f, g, h, g? Is it x squared minus a squared all over x minus a for x not equal to a? And then that one was 8, right? You were supposed to make this puppy what? Not that puppy. Make this function continuous, I think. Right? Is that the objective? Okay. How do you make it continuous? We look for the separator, especially when he's the discontinuity, and we say, hey, it has to equal the limit. Now, guys, why did the book and why am I plugging in the top piece for the limit? AJ, let's come back to you because this was kind of your question. Why am I just looking at this piece for the limit? Yeah, I'm not looking at the at. I'm looking at the, yeah. And this one approaches the above and the below. They're both encapsulated in that guy. So then you that's why we do the difference of squares. You can cancel out the whole. When we cancel out the whole, I know some of you didn't like the a, but don't we always just take whatever is here and plug into the x spot? Always, 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 always. So that's why a plus a ends up being 2a. But what's going on this side? How did they? Yeah, it's just what? You can plug in 8. And that's how they got a is equal to 4. You only had one variable to find in that one. Does that make sense, my ones that were stuck? Okay. I didn't remember if it was your class or the other class, so I graded them both. But I know that at least people got stuck on that one. Number 102. Were you guys okay on 99? This is where IVT started, right? You guys okay on 199? No. What's going on 99? I might not do the entire reading of the problem, but the long story short, didn't they give you a function? Right? And then they gave you an interval 0 to 5, and then f of c equals 11. You were supposed to verify the intermediate value theorem applies. Now on 99, pause. If you're stuck, did you go watch the video? Okay, so 99 is the pink one. You can scan the QR code, or you can go on CalcView, which is under CalcChat. You can watch the video. That would have helped. So let's peek at 102, because that's the one that we're checking, and then let's see if that applies to 99, because they're the exact same set of directions, right? Okay, so what's the function for 102? x minus 1. And the interval is? Are they closed? Good. And then your f of c? 6. Okay. In order for IVT to even apply, first of all, f has, is f continuous everywhere? No. Where is f not continuous? But is f continuous on the closed interval 5/2 to 4? Yes. Why? Isn't this 2.5? Okay. Well, 1 is not 2.5, or it's not in between 2.5 and 4. So therefore, it's continuous everywhere because its discontinuity is not even in the interval. Does that make sense? Okay. What else has to be true? IVT. Ooh, for a quiz on Monday. A question could be theorem. Whole thing. Okay. So I'm just reminding you guys, you have to have the cards memorized. Pause. Even though it could say state the intermediate value theorem, the whole thing, or state the definition of continuous, the whole thing, I would not say state from higher basic graph card. I wouldn't do that. That's dumb. But I would say, hey, graph of e to the x, or who has a function, or which function has a graph of this. Does that make sense? So I could, like, what's one of the Pythagorean identities for trigonometric functions? What's sine of 7 pi over 6? I could have some fill in the blank, but the bigger cards, I could just say state the whole thing. And just a warning, if there are some bigger cards, there's always a state the whole thing. You just have to either gamble, maybe be horribly wrong as to which one I choose, or memorize them both and be ready. Why am I saying? Intermediate value theorem. If a function f is continuous on a closed interval a to b, and if there is a value k within f of a and f of b. Ooh, we need to check and make sure that 6 is in between f of a and f of b. I think we did this yesterday. How can we make sure that 6 is in between f of a and f of b? We say, well, hold on, what's the y value here and what's the y value there? We need to figure out the range of the y values because intermediate value theorem says for a continuous function, all the in-between y values are guaranteed to happen at least once for some value c, x equals c between a to b. All the in-between y's are guaranteed. Well, who are the in-between y's? Well, I don't know. These are the x's. Go plug in. And what'd you guys figure out when you plugged in 5/2? Anybody already do that? 27? Even? No, it's okay. 5/2, that'd be 25/4 plus 5/2 would be 75/4 over 3/2. 75/4 times 2/3 would be 25/2. Did anybody get there before? I did a lot of math super fast. That might be horribly wrong. I'll do the 4 one as you guys double check my other one. 4 squared is 16. 16 and 4 is 20, and 20 over 3. Has anybody checked it yet? Oh, 5. No, I'm off. That'd just be 35/4. That's gross. $35/6. Yeah. Okay. And for those of you guys that are like, I don't know what these numbers are, well, you might just need to think about what they are as mixed numbers, because wouldn't that be, remember, we just have to figure out whether or not this is true, whether or not our k or our f of c is in between. Wouldn't that be something like 5 and 5/6, right? And wouldn't that be 6 and 2/3? Does it work? Whew! All right. So the 2 conditions of IVT are met. A function is continuous on the closed interval a to b, and the k is in between f of a and f of b. And if those two conditions are met, then there must be some value c, a to b, such that f of c, which would be c squared plus c all over c minus 1, must equal k. So how do we find this guy in between there where f of c, the function with c instead, is equal to k? We solve. So multiply c minus 1 to the other side. Don't kill a seal, distribute. Move everything to one side. C minus 2 and C minus 3, you guys agree? Dun 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 dun, wrong. Half right and half wrong. Didn't we just say C had to be in between what to what? Who doesn't belong? The 2 is not guaranteed. The guaranteed by IVT value is just 3 because of that condition. Me quoting the theorem in my head is what allowed me to go through the entire process. Whew. But some of you guys should have just had your notes open and been like following along and saying, what am I supposed to do next? AJ, do you think that might help on 99 a little bit? Like the Ryan.
So when we're saying the intermediate value theorem, can we just give like our own head definition, or do we have to give the weird one?
Well, here's the struggle. Your own head definition wouldn't really be a definition. It could be your own head way of remembering the big idea. So there's a big idea, which is great to start with, or it's great for your brain to attach to the right theorem, intermediate value theorem. In between y is guaranteed. Okay, let's go. But the problem is, in between y is guaranteed wouldn't get you the information you need to solve the problem. Does that make sense? You need your two ifs and you need your then. So that's why the big idea in your head is excellent for you to attach some understanding of whatever all the blah, blah, blah is, but then you need to have the technical blah, blah, blah memorized. Does that make sense? Okay. Does that make sense to the rest of you guys with the forever quiz on Monday? How to prepare, how to be ready? Someone give Michael a pat in the back and be like, you got this, bud. Give me an A. Give me a B. Give me a CalcAB.
CalcAB, let's get it.
Thank you. There we go.
There you go.
All right, section 1.5. What were you doing in 1.5? What were you seeing? Vertical asymptotes. How do you know it's a vertical asymptote? Number over 0 when you plug it in, or you look at it and what does it never do? Never crosses out. Who are the discontinuities that cross out? Not vertical asymptotes. Removable, aka holes. Number 2, coming from above, should have been positive infinity. Coming from below, negative infinity. Was that check the behavior ones? So coming from above, positive infinity. Coming from below, negative infinity. Number 4, they only said come from above. How many of you guys hated this one? Secant. Ugh. Secant. Isn't secant 1 over cosine? So unit circle, if you were thinking about secant, raise a hand. How many of you guys were like, I didn't like it and I couldn't have done it in my head? Okay, the majority of the class. This is why I'm talking about it for a second. Unit circle. On the quiz. Ooh, covered on the quiz Monday. So if you were to plug in, some of you didn't even know that secant of negative 2 pi over 4 was undefined. This would be secant of negative pi over 2. Right? Negative pi over 2. Isn't that the point 0, negative 1? And isn't secant 1 over cosine? And cosine 0? So that's one way of thinking about it. Another way of thinking about it is, wait a minute, don't we know that secant just bounces off of cosine? Isn't it one of our basic graphs? So couldn't we have thought of secant himself? Pretend these actually meet like they're supposed to. With little baby. Where are they telling us to go towards? Negative 2 from above, which means going towards negative pi over 2 from above. Hey, could we have just looked at the graph and without even testing? This just tells us number over 0. Oh no, infinity and beyond. What do? This one, if we think about secant's graph, oh, we're going towards negative pi over 2 from a little bit of positive infinity. Dun, 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 dun. Which one's easier? Having to think about, wait a minute, what's negative 1.99999 plugged into a secant function? Or the graph of secant? Hey, look, it's swooping up. I think the graph. Okay, coming back. Number 6, can you guys read it? Did you need to write those sentences? Please no. The long story short, from below is positive infinity and from above is negative infinity. Is that okay? What did they do? They did like 3.99 and 4.111, but all you were doing was attaching the infinities and checking the sign. Were we able to do it on our own? For the most part? If not, come in. We can work through examples. Number 8. What? They both agree. Shouldn't you know that from the basic graph? Doesn't a 1 over x squared always agree? Wait a minute. Hold on. That's going up. This one says the answer is negative infinity. What made it different? Flipped it down. And so then they both, there we go. So either the basic graph would have helped, or you could have plugged in. If you plugged in 3.9, and if you plugged in 4.1, both of them are going to square to be positive. Doesn't matter, but this negative infinity. Somewhere in here, you guys just started doing like discontinuities. Number 12, a table. Were you guys able to read the table? More and more and more and more negative infinity. More and more and more and more positive infinity. So coming from below, negative infinity. Coming from above, positive infinity. But could you have also thought about the graph of cotangent and thought as you were going towards negative 3, that'd be negative pi? They did the transform graph. That's mean. I would have thought of the normal cotangent graph and cheated just a little bit. But technically, the point of the problem was using a table, so we'll move on. I don't know where I'm going. I apologize. Number 20. No vertical asymptotes. Why was it a hole? Did anybody try plugging in 2? Was it number over 0? 0 over 0. Psh, it's a hole without even doing all that work. How do you find the limit? Is this hard? Yeah. There's like a thing to memorize. SOAP, same, opposite, always positive. There's a thing to memorize to get from here to here. But long story short, what could you have done instead? Do you guys remember how I would advise you to go about factoring that? Starts with the D and ends with the division. Do long division or do synthetic division and ask yourself, how many times does this go into that? Guess what you'll get? This guy. But when you do long division, don't you have to do 1x cubed plus 0x squared plus 0x minus 8? When you do synthetic, it'd have to be a 1, 0, 0, negative 8. Long division could have gotten you to this guy. Then all you had to do was plug it in. The limit's 12. Okay. I skipped one. Negative 3 is a vertical asymptote. Who didn't like that? Because it had an ln, so automatically your brain was like, ew, I don't know what I'm doing. Okay, look around. It's half the class. Okay? But basic graph of ln. ln, normal ln, always has a vertical asymptote at 0. Now, as soon as you start transforming, what's the 0 going to be? Negative 3. So I have an asymptote at negative 3. Or if you want to think about it, didn't ln just shift 3 to the right? 3, sorry, right as in correct, my bad. Didn't 3 ln just shift 3 to the left? There it is. Pretty 1, 0. It should have connected right there. Or, didn't we talk about domain? And doesn't domain always have to be greater than 0? So you could have gotten greater than -3. And if you knew the graph of ln, what's stopping it? A vertical asymptote. So guys, you got to get those basic graphs down. They help, they help, they help. Number 44, negative infinity. He was weird too. Can someone explain how they figured this guy out? Let me get a picture of it. Can someone explain how they figured out negative infinity, if you got it right? Patricia, go ahead. Okay. Is that the very first thing you did? Did anybody do something right before that? Her brain went the right direction. She knew what to do. Plugged in. What number? Oh, separate them first. Yeah, I like that idea, Rachel. I would think plugging in 0 first. So I'm going to plug in 0 first. Then I'm going to separate, and I'm going to use Patricia's idea of 0.1. I'm going to use all three. Okay? So first of all, if you plug in, wouldn't it be 6 minus 1 over to infinity and beyond? I know there's a vertical asymptote somewhere. Does that make sense? Okay. So now that I know there's a vertical asymptote somewhere, then I'm going to be like, okay, well, wait. Let me put this actually above. Be like, some sort of plus minus infinity with a question mark. Then you're like, but wait a minute, isn't the 6 fine? So then we could use Rachel's idea of, hey, we could just take the 6. Okay, what's the limit of any constant? Now I have my number over 0. Okay, check the sign. So now plug in 0.1. If this part is infinity and beyond, if we plug in 0.1, wasn't 1 going to be a positive if you plug in 0.1? And what if you plug in 0.1 cubed? What sign is that going to have? So I can say, oh, hey, this is going to be a positive infinity. But wait a minute. Minus ever-increasing numbers. 6 minus ever-increasing numbers. What's going to happen to the overall problem? It's going to go more and more and more and more and more and more and more negative. Does that make sense? Good. You can break these problems up. 52. Did anybody like 52? There was no vertical asymptote. Really? Why? You might have thought there's sin in the problem, but there's really not. Before you ever stress about the little positive, you just plug in like we just did a second ago. That was Janelle's advice, just plug in. So plug in 0. What's e to the 0? What's anything to the 0? What's sine of 0? What's 1 times 0? Ah! It was just a plug it in, plug it in. Plug it in, plug it in. All right. But what should you do in your color pen right now on that problem if you put a big old question mark? Plug it in. Always first. Use your color pen. Tell yourselves what you forgot, what you didn't do. What's going on here? Did you guys, first, did you see that a negative times a negative is a positive? So 1 over 1 plus 1 is 1/2. This guy wasn't the problem. Like Rachel was saying, we could split it up. So this guy is 1/2. Cool. 1/2 minus tangent. I know some of you guys, don't we have basic graphs? So think about your tangent graph, right? Doesn't tangent? Normal tangent. Basic tangent. Doesn't it? Right? Normal tangent? Basic tangent? Swoop, there it is. Okay, so when we go plugging into tangent, -1, wouldn't this be tangent of negative pi over 2? And what direction are we coming? From below. So we can think, even though I know we're not drawing this tangent specifically and looking at -1, we're saying tangent of negative pi, well, a tangent of negative pi over 2 doesn't exist, but we're not coming from above, we're coming from below. So as you come from below, what's going on? Let's go into infinity. So plug in infinity and then mind not as blown this time. 1/2 minus infinity, minus ever increasing, negative infinity. (62), why is it no? Denominator, set it equal to 0. Plus or minus the square root of -1. What's the square root of a negative number? Not positive. You guys saw what I just did, right? How would you find the vertical asymptotes? Wouldn't you set equal to 0? And if you subtract 1 and square root, oh, it's imaginary. Nah, just kidding. There are no real zeros. That's why it says none. There's no way to make a squared plus 1 equal to 0. Did we have any more? Okay. Section 1.6. Did I miss any odds along the way? Ale? 35? Infinity over infinity is actually indeterminate. But it shouldn't show up until section 1.6, degree test. Degree test. Couldn't you have an x cubed over an x squared? You don't ask yourselves infinity over infinity, what do? You ask yourself, who is stronger? Whose infinity is stronger? If it's an x cubed over an x squared, the top wins, so therefore I'm going to infinity. If it was an x squared over an x, the bottom wins to 0. Ponder it, we're coming back. Number 35. Are you doing non-removable, removable? Is that what's going on? Oh, no, you're checking -1. Got it, you're checking -1. Ali, you have the function, right? Real quick. 35 is f of x equals?
X squared plus 1 divided by x plus 1.
They're asking what's -1. It's as easy as 0 over 0 or number over 0. Plug it in. It's as easy as 0 over 0 or number over 0. Not as easy as that. So if you plug in -1, a negative squared is a? So we can think f of -1 is equal to 2 over, it's a vertical asymptote, non-removable all day. Does that make sense? Cool. AJ. Okay, number. $33? Ooh, good question. I saw multiple ones of these. I think it was mostly period 6, though. 1.4. Sorry, this was 1.5. Square root of 49 minus x squared. You're supposed to be thinking about the domain -7 to 7. I'm saying, first of all, -7 to 7, plug in -7, it'll be 0. Plug in +7, it'll be 0. Plug in anything in between, it'll be square root of a positive, which exists. So I'm saying, first of all, the points all exist. That's condition 1. The points all exist. And I can also the limit which is C for all C within. If I do anything in between, I'm totally good. Exists. That's, let's see, number 1, number 2. Now I'm doing definition of continuous on a closed interval. I can say as I come from above -7, where I'm approaching is where the point is. Say the limit as I come from I can even say it equals f of c. Sorry, I probably should have done that. All the limits equal all of the points in between, and as I come from above, it equals the point. As I come from below, it equals the point. So therefore, everything matches up continuous. But another way of saying it is, it's a semicircle, and look, no holes, no breaks, no jumps. But that's a very non-definition way of saying it. But yeah. All right, anything else? 1415, going once. Going twice. Section 1.6, horizontal asymptotes. Horizontal asymptotes, the very last section. We did vertical asymptotes in 1.5. Now we have horizontal asymptotes in 1.6. You got this. In section 1.5, and the air's on. It's a good day. Section 1.5. And else it keeps you just kind of twitching during class, right? Okay, section 1.5. I know. Section 1.5. The tables look weird, not because of the approach, because you were doing 1.9, 1.99, 1.999, 2.1, 2.01, 2.001, not because of the approach. The tables were weird because, hey, that one, oh, where was it? I think it was section 1.5 at the beginning, right? There was a table. This guy. How was the table weird? Did you see the values getting closer, 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 closer? The y is getting closer, 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 closer to one number. To one number? To two directions. Wasn't that negative infinity and positive infinity? It wasn't getting like closer, 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 closer. That's what was weird in 1.5. And 1.6, what's going to be weird? Our numbers to go to positive infinity. How could you use your table? I don't know. Plug in 5, plug in 500, plug in 5,000, plug in 5. Okay, see what I'm doing? What's weird? I need x to go to infinity, so what do I need my values to do? Get big. Get how big? Get really big. And what am I looking at? Whether or not the y values are approaching a single constant. Why did I choose 5? I felt like it. Okay. So you guys, what's a number you feel like?
12 million.
A small number you feel like. We'll do the 12 because I heard the 12 first, and it has a 2 in it, and then the 6, well, that's number of the devil. So let's do negative 12.
12 divided by 2.
I was trying to think of a reason why not to do 6. Okay. What's x approaching if I'm plugging in this? Why negative 12? Because Nick said 12. I said sure. Doesn't matter, right? Limits at infinity. The table's just going to be weird because you're going to have to just have the x's get bigger and ask yourselves, are the y's leveling off? Have the x's get more negative? Are the y's leveling off? Leveling off? What am I talking about? There will be a horizontal asymptote at y equals L if the limit as x goes to infinity of f of x equals L. And what do I mean by L? A constant, a number. What's going to happen down here? A horizontal asymptote if y equals L, which will only be true if the limit as x goes to negative infinity of f of x is L. Starting Monday, we're going to try to have AJ, Christina, and Ryan switch groups with Rachel, Rebecca, and Grace. Okay? So just groups will switch. Oh no! How can you you attempt 1.6, which will not be due on Monday. However, we're going to start reviewing the second half of Monday. How could you possibly start this over the weekend?
Watch CalcAB.
It's degree tests. It's degree tests. This homework won't be due until 7 a.m. Tuesday. However, what is on Monday? A forever quiz. And what else is on Monday? I'm going to post a practice test on your Google Classroom you might want to start playing with. Test is on Wednesday. Bye, guys. Later, Gators.